All right, let's just jump right in. I want you to imagine the universe as the ultimate detective story, a cosmic mystery, right? It's filled with these unseen forces, these hidden characters that are shaping everything we see. Today, we are on the case, and we're going to track down the two biggest suspects in this cosmic whodunit, dark matter and dark energy. And just look at this. This chart right here puts the sheer scale of our mystery into perspective. I mean, everything we've ever known, every star, every planet, you, me, all of it, is crammed into that tiny 5% slice called ordinary matter. So what about the other 95%? Well, that is the giant cosmic puzzle we're here to solve. So yeah, that 95% is dominated by two absolutely enormous unknowns. Our investigation really kicks off by trying to understand these invisible influences that are secretly running the show, governing the entire cosmos. And here they are, our two main subjects. On one hand, you have dark matter. This is some kind of massive, invisible stuff whose gravity we can actually feel pulling on things. And then, on the other hand, you have dark energy, this completely bizarre, repulsive force that's actively pushing the universe apart. Two totally different phenomena, both completely invisible to us. Okay, let's start with our first suspect, dark matter. The case for its existence didn't come from anyone seeing it. Nope, it came from watching how other things moved, specifically how entire galaxies spin. Now this is the smoking gun. A galaxy should spin kind of like our solar system, where the planets farther out move slower. That just makes sense. But that's not what we see at all. Observations show that the stars on the very edge of a galaxy are moving just as fast as stars near the center. And the only way that's possible is if there's a huge amount of unseen mass out there, providing a ton of extra gravity. And this leads to an absolutely mind-bending conclusion. The bright, starry part of a galaxy that we see in pictures, that's just the tip of the iceberg. It's actually sitting in the middle of a much, much larger, totally invisible halo of dark matter. It means the part we see is just a tiny fraction of what's really there. Okay, so a flat rotation curve is pretty compelling. But for a claim this big, you're going to need more than one piece of evidence, right? So astronomers started looking beyond single galaxies to the largest structures in the entire universe, clusters of galaxies. And what they found was basically a trifecta of proof. First off, the individual galaxies inside these clusters are moving so incredibly fast, they should just fly apart. But they don't. Second, the gas between the galaxies is unbelievably hot, way too hot to be held in by the gravity of the stars alone. And third, the cluster's gravity is so strong, it actually bends the light from even more distant galaxies behind it. And the amount of bending reveals a mass that is way, way bigger than what we can see. Three totally different methods, all pointing to the exact same conclusion. Just let that number sink in for a second. It's not double the mass, not 10 times. It's 40 times more mass than we can account for from the stars. At this point, the evidence for some kind of invisible matter is just overwhelming. Okay, so we're convinced something is out there, but what in the world is it? The next phase of this investigation is trying to pin down the identity of this dark matter. So broadly speaking, there are two possibilities. Could it be just ordinary matter, but in a form that's hard to see? Like a bunch of black holes or dim planets? Or is it something truly exotic, something completely new to science, a whole new kind of particle? Well, it turns out that our calculations of what happened in the Big Bang tell us almost exactly how much ordinary matter there should be in the universe. And it's not nearly enough to account for this. So that points us toward an extraordinary explanation, a new type of particle. And the best bet is something called a WIMP, a weakly interacting massive particle. It has mass, sure, but it barely interacts with us or with light at all. So, if dark matter is real, what does it actually do? Well, it's not just sitting around. It turns out it's playing one of the most fundamental roles in the entire cosmos. Get this, dark matter is basically the universe's architect. Its immense gravity acted like a cosmic scaffolding, pulling together the very first clouds of gas so that they could collapse and form the galaxies we see today. It's the silent, invisible force that literally built the cosmic web that defines the entire structure of our universe. But just as we start to feel like we're getting a handle on dark matter, the universe throws a massive curveball. It turns out there's a second and maybe even more profound mystery at play. You see, for most of the 20th century, the biggest question in all of cosmology was this. We know the universe is expanding, but is gravity slowing it down? I mean, it has to be, right? Will it eventually stop? Or maybe even collapse back on itself in a big crunch? Everyone, and I mean everyone, just assumed the expansion had to be slowing down. But when astronomers finally used distant supernovae to measure the expansion rate, they found the exact opposite. Yeah, you heard that right. The expansion of the universe isn't slowing down at all, it's speeding up. Something is pushing back against gravity and it's winning. And the name we give to this mysterious anti-gravity force is dark energy. It's some kind of repulsive force woven into the very fabric of space itself. And it's winning the cosmic tug-of-war against gravity, forcing galaxies farther and farther apart, faster and faster every second. The discovery of dark energy didn't just change our understanding of the universe's past, it completely rewrote the story of its future. This crazy accelerating expansion, what does the end of the story even look like? If dark energy is now in the driver's seat, where is all this headed? Well, the outlook is strange and kind of bleak. The expansion is going to keep accelerating until distant galaxies are moving away from us faster than the speed of light, effectively disappearing from our view forever. Then, over trillions and trillions of years, the stars will all burn out. Matter will either decay or get swallowed up by black holes. And then, get this, even the black holes themselves will eventually evaporate into nothing. The universe will end not with a bang, but as a cold, dark, and infinitely dilute soup of particles. The long goodbye, indeed. So that's where our investigation leaves us. Not with all the answers, but with this profound understanding of how much we still have no idea about. With 95% of the cosmos made of things we can't see or even comprehend, you have to realize the greatest detective story of all time is really just getting started. What other secrets is the universe hiding? What are we going to discover next?